Ladies and gentlemen, a warm welcome to this particular session of the IRS 10, which is under the theme of digital innovation, where we are specifically looking at how we can possibly accelerate the digitalization of infrastructure. A very, very illustrious panel of speakers, and in this particular session, I'm delighted to introduce. In no particular order, but Rolf Hardi, who is the Chief Technical and Innovation Officer for Innovation and New Technologies at Deutsche Bahn in Germany. I'm also delighted to be able to welcome Martin Mason, who is the Director of Predictive Maintenance at Network Rail. Also Thomas Boehm, who is the Head of Product at KONUX, who, as you will see, are sponsoring this particular session. I'd like to stop all of that chit-chat and hand over now to Rolf Hardi, who is Swiss by birth, but has had an engineering background with and companies like ABB, and been in the sector for a considerable amount of time, but has been most recently with Deutsche Bahn since 2017, and someone that we've come to appreciate because he also was the chairman of our safety platform at the UIC for a period of time as well. He's going to give us a bit of an overview of his perception of the program that Deutsche Bahn is undertaking in this particular field. Rolf, the floor is yours.
Well, thank you ever so much, Simon, and thank you for having me. It's a great honor and pleasure to present here. I'll start with a quick introduction, very quick, on Deutsche Bahn. We are a fully integrated provider having trains and infrastructure. You will see here some of the figures. I will not bore you with those figures, but we're probably not the smallest railway provider within Europe, and of course digitalization is a big challenge to us, and we do believe that digitalization is the way forward, and we have focused on that. And although we're talking about infrastructure, I like to point your attention to the overall picture. We strongly believe that you have to look at digitalization in a more coherent way, and that this is how we're approaching it. So we're looking at the entire ecosystem and how can we optimize that using digitalization. And you see here some examples right through the entire value chain. And what we're also doing is we are approaching the so-called four-quadrant approach, which basically means infrastructure is controlling infrastructure. Infrastructure is controlling vehicles. Vehicles are controlling vehicles themselves, and vehicles are controlling infrastructure. By that, and connecting everything to one virtual network and information lake, we approach digitalization. And everything we do based on use cases. For instance, one example you definitely see later on, KONUX is also in this session. We're just implementing 3,000 switches, additional switches, where we do condition-based monitoring with artificial intelligence on that. Great. Okay. We have started a strategy, and in this strategy, which is very coherent, we're focusing on technologies. So together with the sector, we are pushing those technologies forward, having projects together with the industries. We are piloting digital twins. We're looking into artificial intelligence, very much on ATO, ETCS, and so on and so on. So there are 18 technologies we are pushing very hard, and what we call 10 foundations is also technologies which more a foundation character, like connectivity, cloud services. We have, in the meantime, 100% of our IT is in the cloud. So we are pushing these technologies in 6 distinctive use cases you see here on the top, from digital rail operation to digital maintenance, to digital customer experience. Again, having this coherent approach. What we also do is, especially to test the efficiency of the infrastructure with digitalization, in the 4-quadrant system, we're having a dedicated test train where we can test the effectiveness of the interaction between infrastructure and the trains. This is a 605 ICE train, diesel. It can go anywhere. We actually been driving through Berlin the other week, believe it or not. Here you see we're testing camera systems. We're testing all sorts of sensory communication, alternative propulsion systems, and so on. And this has proven very valuable to do. Because we do enable all the industries and the startups that are coming to that to test the systems in live conditions. And we do believe this is a way to accelerate digitalization quite a bit. This is a concrete project we're doing in Hamburg. This is going to be the first fully automated S-Bahn. We actually want to go live this year, where we have a pilot line of 23 kilometers, and we have modernized 4 vehicles, and they will fully operate autonomous. We still have drivers in the cab for safety reasons, but this will be the first implementation of a fully automated S-Bahn Deutsche Bahn is doing, and we're quite excited about it, and the project is on track, and it really looks good at the moment. And we, of course, you can do all sorts of pilots, but on the end of the day, you have to invest, and we are in a fortunate position where we can invest in infrastructure projects. This is right across the entire spectrum, but you see here some of the figures. We invest in 108 billion euros of projects. We do expand the lines in order to make sure we have all the capacity we need. We do have over 46 projects under construction, and alone in 2019 to 20, same figure actually. We do spend 2 million every year. So we are really in a implementation modus where we're going to implement infrastructure projects, and all these projects will have a focus to complete this digital plan we have foreseen. What we also do, since actually quite a few years, we're working intensively together with startups. What you see here is just a selection. So please do not disappointed if your name doesn't appear on it. Actually, in the meantime, we are collaborating with more than 100 startups. KONUX, for instance, was a startup a few years back where we started having first trials, and now it has become a supplier of Deutsche Bahn. But we do strongly believe that there's so many good ideas out there, especially in the digital world, where those startups need a good partnership. Somebody helps them to translate the idea into a final product, which is going to pass all the safety regulations and all the authorities. And this is really what we are focusing on, and together in this coherent approach with startups, with the spirit, pushing digitalization forward. And that would end my presentation. Thank you very much for listening patiently.
And then meanwhile, what I'd like to do is just introduce us to Thomas, who is, as we've already said, the head from KONUX, who are sponsoring this particular session, and Thomas is the head of product. And Rolf described you as a startup a few years ago, and my thought immediately was, well, we all have to start somewhere, and so that's a fabulous. But it's fabulous that you've been able to develop the product and develop the company, and of course, with your insight, technical knowledge and insight. It's interesting to be able to have organizations that can zoom in on a particular issue, and And it was interesting that you've also been involved in German aerospace DLR. That's another organisation we know very well because they're very much involved in railway technological projects. Thomas is going to give us a bit of an overview of what KONUX is doing in order to help to speed up or to accelerate infrastructure digitalization. Thomas, the floor is yours.
Thank you, and welcome everybody, also from my side. I'm happy today to speak to you about actionable insights easier, the KONUX Predictive Maintenance System for railway switches. We at KONUX strongly believe that a lasting change in railway can only be achieved if we put railway first. And we're doing this by integrating the deep railway knowledge in our development, in everything we think about, and fuse it with artificial intelligence and Internet of Things. So unlike a horizontal player, where you have different technologies that you try to apply to different industries, we're vertically exclusively serving the railway industry and doing so quite successfully. I know it's not an approach for everyone, but for us, it has turned out to be that path to success. You can see this year we have over 50 million train passages recorded. We are deployed in 10 countries, and among those countries, there are some of the most innovative and advanced infrastructure managers you can find, like Deutsche Bahn, as said in the beginning by Rolf, but also Infrabel, Trafficwerket, and so on. And we're now collecting data for more than 4 years. And this is what fuels our product and what helps us to digitize. And of course, we're here because we have a mission. Our mission is to make railway the mobility choice of tomorrow by increasing capacity, reliability, and cost efficiency. And we're not saying that we do this alone, but for sure we want to be the driver for this and helping very much to achieve that mission. But when you look at the demand, passenger kilometers will grow almost double until 2050. Freight train demand or freight demand is not far behind this. So the question is then, how can infrastructure deal with that high demand for mobility? And digitalization is supposed to help and pave the way for this increase of demand, for this increase of capacity, reliability, and so on and so on. But also we see that is not as easy as maybe thought in the beginning. And as the poll already reflected with the answers, is that, yeah, you have some challenges. And most of you answered, 54% answered to the question, what is the biggest challenge for infrastructure managers and railway operators? Implementing process changes. So it's not just done with a technology, it's not just done with an algorithm, it's really when it comes towards the user, when it's part of their process that has changed towards a digital process. Because the human will still be in that system. And that's why we have built this software as a service system, our predictive maintenance system, and I will tell you in a few seconds what it does, is deployed in a switch, and it's capable of improving the availability of switches by up to 45%, reducing OPEX by up to 30%, with optimizing maintenance, especially optimizing the inspections, so how much and when you do inspections, and increasing the asset lifetime by telling you much more targeted when to maintain and what do and what not to do. So how does it work? We applied AI and industrial Internet of Things to deliver a first software as a service predictive maintenance solution for switches. And that means we deliver an insight, we deliver the condition about the system in the hands of maintainers. And everything else, taking care of the system, taking care of the hardware and so on, is done by us. That means we deploy our own autonomous and fully railway certified system into the infrastructure right on the sleeper at the crossing of a switch. And there it measures every train, the acceleration of every train, sends this data to the cloud where the intelligence is, where it's the home of the intelligence. And from that acceleration, we derive many, many insights that we then either visualize via the user interface or provide via an API directly, as I said, in the hands of our customers. And here we had earlier seen in the presentation from Rolf talking about smart standardization as one of his key things. And smart standardization does not mean, for example, in this integration discussion, it does not mean that we provide our own UI or that we just deliver a few data points. With the data comes context. And that context is relevant and is valuable to the users itself. So it's not just done by, here's a measurement value that is now digitally available. No, it comes with context, with the ability to reason about the data, with support of the system. And then we use this context and this data together to monitor the switches, detect anomalies, predict failures, prescribe maintenance, and even validate the maintenance. So our system, as you can see here, has seen many things. Very hot temperatures, very cold temperatures, all kind of different switches in traffic. And it really has proven that we now covered a lot of corner cases and edge cases that initially we never thought of, but are now part of our product and are part of this constant innovation that we're doing. As software as a service, one advantage is that you can easily deploy updates and deploy learning to all customers. One thing that we started on right in the beginning was measuring the vertical displacement, so of a sleeper, voids underneath the sleeper, and how much it moves when the train is passing. And you may wonder, okay, this is one small aspect. What has it to do with availability of the switch? And why is it so important? This is one example where, despite us knowing the displacement and the moving when the train is passing, all of a sudden we recorded a lot of very unusual signals. And we informed the customer, who went out with an inspection team and said, yeah, it's no wonder, because here you see it, the clamps that are fixing the sleeper towards the rail are missing. In fact, they're lying here left and right to the sleeper. And they confirmed that this is not the first time it happened, but until now, they could not be sure why it comes, because when they're there and inspecting the switch, the high-speed trains, this is a high-speed line where trains go 250 kilometers per hour over the switch, they were never present when the train is passing. So now they know the root cause and they can fix it. So it was not only that we measure the displacement, but that we also look in the data for anomalies and detect things that were unusual. We added this case to our, let's say, catalog of things we can find in order to prevent it happening in the future. But there's other aspects too that we derive from this. I mentioned earlier that we record each train. So we also can see what happens after maintenance, for example, temping. And when you ask our customers, what do you do today to know that maintenance was successful? We got interesting answer. Probably one of the most interesting answers is this one: today, you hope. And there is something we can change in here. And we've built a feature that is monitoring the quality of tamping by saying, okay, was it initially successful? So means it has improved the situation of voided sleepers. And then over a period of time, is the settlement and development still deemed to be successful? And this we use to identify and change how maintenance is first initiated, but also how it is looked afterwards as performance and how well it worked and in which situations it did not work. So we looked at more than 100 tamping actions that we have seen with our system, and surprisingly, only 15% of those were still effective after 2 months, meaning that they had reached at least 50% in reduction of voiding below 3 millimeters and sustained this for more than 60 days. So that means there's 85% of inefficient activities, and they're not cheap. Of course, you can argue machine temping, like you can see here, is also done for different reasons, to align the track, to align the geometry. Nonetheless, we have manual temping, where most often in these cases has been done without a necessary cost and rely very much on the experience of maintenance people that are there for 25, 30 years that assess the situation. But still you can see that a data-driven approach might give you much more efficiency. And in fact, in this, the manual tamping events that were done while the condition was still very good, each of those is not necessary, but costs you at least 2,500 euros. And here's data that you can use to better pinpoint when to do it and what to do. Another thing is, and I mentioned this earlier, that we see every train, and we also see what kind of train it was, how fast this train was going, and how heavy it was. So we have the load information. And today, maintenance and inspections is still based on a projected load. And most of our customers don't have any way to really assess what kind of load went over the network or specific assets. And of course, you can take data from operational side, but is the data that the freight operator gives you how heavy the train is really how heavy the train was? And do you get the speed of the train at a particular site in the infrastructure? And think of it, speed, train type, load, and environment are the 4 factors that drive degradation of the network. And we can cover 3 of those, helping you to understand better where to focus on. And that's why we built a load factor that incorporates these 3 things in order to better give insights on when to do something or where to focus on. And you see here in this example, the top 4 assets are all in the same load category. So they're all equally treated in terms of maintenance and inspection. But there's a huge difference. The top asset number 19 has 152 trains per day, all going at high speed. While the asset number 2, the third in this table, has only 125 trains, and it's more towards light passenger trains and high-speed trains as a mix. So this is probably 2/3 of the load that asset number 19 has, but they're still treated the same way. And once you know more precisely what load is on your asset and how it is linked to degradation, you can get away from a fixed time schedule. You can say, I want to have so many load cycles, or I want to have so many degradation before I go there and do something. You would still be able to keep the same safety case and the same safety scenarios as you have today. You're just more tailored to the individual asset. So these are things where you can see that it directly helps the digitalization, and what you do with data and how you support different use cases at a user can help you. But there's also more to this. The system can make the work safer, healthier, more attractive. The forecast that we can provide with a 90-day outlook, it helps to reduce short notice action, meaning that you have less people that are on demand for repair. You have less night shifts, which makes the work itself more attractive and also more healthy to the people. Reducing inspections, reducing failures is less time on the track, and it's less time that you spend for routine checks that you can spend for actual repair or improving the network. And of course, I mentioned the example of maintenance quality check. There you have a tool that helps you to speed up the onboarding of new people. They don't need a 20-year, 30-year experience to assess what to do and when to do. So they're up to speed, they're up to a level of quality much faster. And you have to remember that most of the very experienced workforce will soon retire. And that knowledge needs to carry over to the next generation. So there's a lot of things that within that small use case of a switch and measuring acceleration, we were able to build and to support. And we are, of course, hoping that we can do much more in the future. Thank you.